So we're going to analyze this truss system using the graphical method, and this is perfect for anyone who struggles with the analytical method, which involves a lot of calculations. The graphical method is just as good as any other. It allows us to find the internal forces for each members. So let's start, and the first thing that we need to do is to find the reaction forces. So let's do that. So here we're going to take the sum of the moments about point A right there, and we have three forces that are trying to rotate this system. Force 350 newtons trying to go clockwise, that's 675 newtons trying to go clockwise as well, and we have RD that's trying to go counterclockwise. So when we set up our equilibrium equation, we're going to now say that the sum of the moments about point A should be equal to 0 because we're in equilibrium, and then we're going to take the clockwise moment to be equal to counterclockwise moment, and we do our calculations. So the first force, which is that 350 newtons, and you can see the line of action there acting at 2 meters. So we will end up with that 350 multiplied by 2. Then we sum the next force, which is 675, and we see the line of action there acting at 6 meters. So we have 675 multiplied by 6. And then we move across to the next force there, which is our RD, and RD is 8 meters away. So what we have now, we have RD to solve for, and RD will be equal to 350 times 2, so that's our 700, plus 4050 for 675 times 6, and all divided by 8. So our final answer for RD is 573.75 newtons. And on to finding RA. So for RA, we're going to just say that the sum of the vertical forces should be in equilibrium, therefore they're equal. And if we were now to just sum all the forces going upwards, they should be equal to the sum of all the forces going downwards. And what we have going upwards, we have RA plus what we just found for RD, which is that 573.75 newtons, and that should be equal to our 350 plus 675. So all we have to do, we just need to sum those two and subtract our RD value. So the final answer is RA should be 431.25. So that's RA. Now we need to find the internal forces in each member, and we're going to start now by using the graphical method now that we have our reaction forces. And just before we do that, if you could just do me a huge favor, subscribe to the channel if you haven't already, and if you give this video a thumbs up, then that will help us to help a lot more people. So on to using the graphical method now. So the first thing that we need to do here is to establish a scale. So in this instance, I'm just going to use a scale of 1 centimeter, which will be representing 100 newtons. And that's because the forces are quite large. So I would like to scale down my drawing so that it can fit on paper. So the next thing that we need to determine is which of these members we have the magnitude, the angle, and the direction for. And we have already calculated RA, and we got that to be 431.25. So that's our magnitude for RA. We know its direction, it's going upwards, and its angle will be at 90 degrees. But for the other two members, those are the members that we're going to try to find because we don't know their magnitudes. So it's safe to say that we're going to start off with RA. And to begin with, I'm just going to use the grid as a guide to draw that vertical line. And in terms of the scale, it will be measuring 4.31 centimeters. So that right there is my drawing for RA. And in terms of its measuring, it should be measured 4.31 centimeters because that's my scale, 1 to 100. And then now I'm going to decide if I'm going to draw in either AE or AB. And because AE is purely horizontal, I'm going to go for AE next. So AE will go across like so. And then now the final thing that I need to do is to determine now where AE will cut off. And to do that, I will draw in the next force member, which is AB. Now before drawing AB, you should draw a reference line to measure that angle. So that very, very thin line at the bottom, that's going to be my reference line, and that's what I'll use to measure the angle. So now I'm going to draw AB and measure its angle. So that's AB going in, and we know that AB, the angle here, should be 60 degrees. So that will be the first scale drawing. And in terms of its measurement, this here will be measuring 2.5 centimeters. And for this next member, we have 5.0 centimeters. And what that will look like now in terms of the actual lengths or the actual magnitudes, what that will look like if we multiply each of these centimeter measurements by 100, then this is what we'll get. So AE will be equal to 250 newtons. AB will be equal to 500 newtons. Now, the only thing that we don't know is whether or not these members are compressive or if they are tensile members. And to figure that out, this is how we do that. So we start off with the first arrow that we know, and that one was the arrow for the reaction. And that was going around like so. So I'm highlighting that now. So all the other arrows will go around in the same direction. So that one will be going in that direction, and they will just trail each other around like that. So what that means now, what that tells us, on our drawing or on our diagram, we're going to insert these arrows exactly the same. So just like we have on the drawing there, AE is going away from the joint like that, and AB is going towards the joint like that. And if the arrow is going towards the joint, then that member is going to be compressive. So for AB is going to be a compressive member, and AE, it's pointing away from the joint, so AE is going to be a tensile member like that. So that's the first joint done, and we're going to go to the next joint and we're going to repeat the exact process. So here we are at the next joint, and we've already inserted all the known values. So we already know what AB is. So AB, we got that previously as 500 newtons. And we already know what that downward force is, which is that 350 newtons. So we're going to start our scale drawing for this member. And our intention, just like the previous one, was to create a closed shape. And how we determine, again, where we start, which of these members do we have the direction, the magnitude, and the angle for. And in this instance, we have two members to choose from. We have that 500 newtons for AB, and we have that 350 newtons that's going downwards. So I'm going to start with that 350 newtons purely because I don't have to draw a reference line for it. So that's representing my 350 newtons. And in terms of centimeter measurements, we're going to say this measure 3.5 centimeters. So now from here, I need to determine which other member to draw next. And because I already know the exact measurement for AB, I am going to go with AB next. So before we draw AB, we need to ensure that we have a reference line. So this here is representing my reference line for AB, which I'll use to measure the angle. So that right there is representing my length for AB. And for AB, we already know its measurement. It's 500 newtons, but we're going to measure this to be roughly 5 centimeters, so 5.0 centimeters. So the next thing that we need to do now is just to simply connect with BC and BE. Now, how we're going to do that, we just need to figure out how these two lines can intersect. So I'm going to start with BC, and purely because BC is just an horizontal line. So how I'm going to do that, I'm going to draw BC across from the tail of our first 3.5 newtons like so. So that's representing my BC. And for BC, we don't know its actual length yet. We have to figure that out after we close the shape. And to close the shape now, final line to connect is our BE. And for BE, I'm going to draw a reference line at the top of our 5 centimeter line there. So that's my reference line, and that's where I'm going to measure that 60 degrees from for BE. So from here, BE should connect like so. And the angle right here should be 60 degrees right there. So we have all our 4 forces, and we have the angles measured, and we use the reference lines to measure our angles to get them accurately as possible. So what we need to do now, we need to just measure these lengths now. So we're going to measure these and get our measurement. So we already know AB was 5 centimeters, and that would be equivalent to 500 newtons. BC is 2.9 centimeters, and that will be equivalent to 290 newtons. BE equals 1 centimeter, which equivalents to 100 newtons. And then the final thing that we need to do now is to determine if these members are either tensile or compressive members. And all we're going to do is just to trail these arrows going around. So that one will be going like so. Keep trailing them like that. So that's it for the arrows in. So what we have now, so if we look at BC, that arrow is going back into the joint. So BC is compressive. And just like before, AB, it's going back into the joint. So AB is actually a compressive member. BE now, BE is going away from the joint. So over here is our BE member, that small compartment. So BE is going away from the joint. So that's in tension. So that's it for this part of the drawing. And what we'll do next, we're going to go to the bottom right corner and do exactly the same thing. So for this one, it's more of the same. We need to determine which one of these members we're going to start our diagram with. And in this instance, we have only RD. So we're going to draw in RD. So that's RD. And as for RD in terms of centimeters, let's say that's our 5.93. And we're going to go to CD next. And as you can imagine, we need to do our reference line there at the tip of that arrow, so that we get CD as accurately as we possibly can. So that's representing our CD. In terms of the angle, we know that that angle here must be 60 degrees right there. So that's our CD. And then finally, we just connect to get our DE. So this is our DE. Done. And what we have to do next, we just need to measure these lengths. So CD is 6.8, and that's centimeters for now. And we get DE as 3.5, and again, centimeters for now. So all we have to do now is trail our arrows around to know what these members will be doing, if they are compressive or tensile. So we start here. So that was going up. And then we keep trailing around. So what we do next is to fill that in on the diagram. So CD should be going towards the joint like so. And DE should be going away from the joint. So in terms of compressive or member in tensile, we know that CD is going to be 680 newtons. And because CD is going towards the joint, then CD is compressive. And we know DE is going to be 350 newtons, and DE is going away from the joint, so DE is a member that's in tension. Now, if you struggle with the analytical methods, which are method of joint and method of sections, then you should check out these videos right here, because they will help you to understand these methods step by step.